So in this question here, we have a scatter diagram which shows information about 12 girls. It shows the age of the girl and the best time she takes to run 100 meters. And then below we have the scatter diagram. So we have age in years on the x-axis and then time in seconds on the y-axis. Now for the first part of this question, we're asked to write down the type of correlation. So correlation between two variables basically is a way of showing how the two are related. So how time in seconds relates to age in years. And as we can see here, as the age is increasing, as the x values are increasing, the time in seconds is going to be decreasing. We can see this negative gradient here. If we were to draw in a line of best fit somewhere down here, there'd be a negative, it would have a negative gradient. So here we're going to have a negative correlation. So as one of the variables increases, the other decreases. Now in the second part of the question, we're told that Christina is 11 years old and that her best time to run 100 metres is 12 seconds. We're told that the point representing this information would be an outlier on the scatter diagram, and we're asked to explain why this is the case. Now, the kind of definition of an outlier is we're looking for something that doesn't fit this this trend that we have here, doesn't fit this negative correlation that we've already seen, and doesn't kind of fit in with the other points and the correlation of the graph. So if I have a look of where this point is going to be, if she's 11 years old, we're going to be at this point on the x-axis, and she runs it in 12 seconds. So the point is going to be drawn in here. And as we can see, if we were to draw a line of best fit over here, showing this negative correlation, this point lies nowhere near the line of best fit and doesn't continue the trend. So to explain why this point would be an outlier, we simply need to write something along those lines, so it's not in line with the trend of the other points, or that it doesn't fit the correlation that we've already spoken about in the first part of the question. We would also get the mark for saying it's far away from the other points or far away from the line of best fit. So now in the final part of the question, we're told that Debbie is 15 years old, and that Debbie says the scatter diagram shows I should take less than 12 seconds to run 100 metres, and we're asked to comment here on what she said. So if I have a look at the age of 15 years old, and go up to about where we'd expect the kind of general trend to carry on to, it would be something somewhere here around sort of the 12 second mark. However, as the points finish here, so the oldest person is somewhere between 13 and 14 here at this point, this is what we know, this is what is known as extrapolation. So we're extrapolating the data and going beyond the points which are shown on the graph. So this can't be said that the results are reliable beyond this point. So the point at which somebody is 15 is going to be outside of the range of the scatter diagram. So we can't really use it to predict how long it should take a 15-year-old. We can't be sure that this trend is going to carry on in the same way that it already has been. So I'm just going to say here that the point would be outside of the original range of the scatter diagram that we have above. And this means that we just can't reliably extrapolate or extend this data to come up with a value that, come up with a time that it should take somebody who's 15 years old to complete the 100-metre race. So in this question, I'm asked to expand and simplify this expression that we have here. So 5 lots of p plus 3 minus 2 lots of 1 minus 2p. So I'm going to need to expand out the bracket so that I can simplify my terms, group some terms together and come to a final answer here. So if I take this first bracket first, I need to multiply p plus 3, the bracket, by 5. And I can do that by taking 5 and multiplying it by p and then 3 separately. So 5 multiplied by p plus 5 multiplied by 3. So I can do 5 multiplied by p gives me 5p plus 5 multiplied by 3 gives me 15. I'm just going to put that in brackets because that represents what I've just done there with the first bracket. And now similarly here, I have this bracket that I need to work with. However, this time we're subtracting. We have in effect a minus 2 here, which we need to multiply the terms in the bracket by. So if I take minus 2 multiplied by 1, and then I need to add on minus 2 multiplied by minus 2p. So I can add on minus 2 multiplied by 1, which is minus 2, and then minus 2 multiplied by minus 2p gives me positive 4p. So then I can add these two brackets together, collect the p's together, and collect the numerical values together. So for the p's, we have 5p plus 4p. And to that we need to add on 15 minus 2. So it leaves us with 9p plus 13. And these values don't share any factors. 13 is prime, so we know we've got it in its most simplified form. We can't factorise anything out, so that's going to be the final correct answer of 9p plus 13 there to gain us the second mark. The first mark was just for starting to expand one of the brackets at the start of the question. So in this question, I have a trapezium drawn on a centimetre grid below, and I'm asked to, on the grid, draw a triangle equal in area to this trapezium. So we need to find the area of this trapezium and then draw a triangle of this area below it on the grid. So a good place to start here is going to be by finding the area of this trapezium. And the formula for the area of a trapezium is going to be half of the sum of the parallel sides times the height between them. That's a common rhyme that's often used to remember the area of a trapezium. So the formula here is half a plus b multiplied by h, where a and b are the parallel sides. So we have a and b here, which can be labelled either way round, and a has a length of 2, and b, if we count the squares, 2, 4, 6, 7 squares. And we're working on a centimetre grid, so we can just count the squares like this. We then need to find the height between the two sides, between the two parallel sides, and we can just find the difference between these two by looking at the vertical distance here, which is going to be 4 squares. So the vertical height, so the height of the trapezium is 4. So we can work out the area by subbing these into the formula. So a half multiplied by 2 plus 7 multiplied by 4. And that gives us an answer of a half multiplied by 9 multiplied by 4, which is 18. So we're going to need a triangle of area 18 centimetres or squares on the grid. And if we know the formula for the area of a triangle, it's just going to be a half multiplied by the base multiplied by the height. And we know that the area has to be equal to 18. We can multiply both sides by 2, so we know that the base times the height is equal to 36. And then we can basically find any two factors of 36, a factor pair of 36, so two numbers that multiply to 36, one of which will be the base of the triangle and one of which can be the height of the triangle. So simply here, I'm just going to take 6 and 6. So if the base is 6 and the height is 6, they multiply together to get 36. You could do 9 and 4. And then I'm just going to draw out a triangle of height 6. So it needs to have a height of 6 here. And then it needs to have a base length of 6 also. And then I can just connect these lines here. And I now have a triangle of area 18 centimetres, which is going to be the same as the trapezium. The first mark's awarded for finding the area of the trapezium, and then the second is for a correctly drawn triangle. So in this question, we're told that when a biased six-sided dice is thrown once, the probability that it will land on 4 is 0.65, and we're told that this dice is thrown twice. Amir draws this probability tree diagram, and the diagram is not correct. So if I have a look at the diagram, we can see that on the first throw, the probability it lands on a 4 and doesn't land on a 4, and then similarly on the second throw, having landed on a 4, it either then lands on a 4 again or doesn't land on a 4. And with this information in this tree diagram, we're asked to write down two things that are wrong with the probability tree diagram. So, especially when it comes to tree diagrams, I feel like a good place to start is going to be looking at what the probabilities sum to. So in each branch, in each kind of section of the tree diagram, on each throw, the probability of it landing on a 4 and not landing on a 4 need to sum to 1, as these are the only two outcomes that can happen. The probability of the sum of their probabilities must be 1, as these are the only two things that can happen. So if I have a look at the first branch, we have 0.65, which, yes, it says in the question, is the probability it lands on a 4. However, here we have 0.25 that it doesn't land on a 4. Add these together, and we're not going to get a total of 1. We're going to get 0.9. So that's the first thing that is wrong with this diagram. And if I carry on having a look, if we then go over to the other branches, I can see that the probability of it landing on a 4 again should be 0.65, because this is a new throw of the dice. There is a 0.65 probability that it does land on a 4. However, here we have a probability of 0.35, and the 0.65 is here. So these two are swapped. These are the wrong way round. The probability that it lands on a 4, despite it being the second throw, is still the same, and this one should be 0.65. So I can then just kind of put these ideas together and write up my answer. I've now found two things that are wrong with the tree diagram. And in the first box, I'm simply going to put the probabilities should always sum to 1. So 0.25 should be 0.35, and it's always a good idea just to kind of give an example of what you mean here. And then secondly, that for the second throw, the probability that this dice lands on a 4 should be 0.65, not 0.35 that it says in the tree diagram above. So that's for basically saying that the 0.35 and 0.65 are reversed. We get a mark for each of these ideas for getting a correct answer for each of the two things that are wrong with the diagram. Each one gives us a mark here. So in this question, I have ABC, which is a right-angled triangle, and then I'm given the diagram below, and I'm asked to work out the size of the angle ABC, giving my answer correct to 1 decimal place. Now, the angle ABC is going to be the angle between the sides AB and BC, so this angle that we have here is what we're looking to find. Now also, I'm noticing here that I have two side lengths of the triangle. So I have this length here, which is 7, and then as this is a right angle triangle, I have the length opposite the right angle, so I have the hypotenuse of the triangle here. Now, I'm thinking that I've got two side lengths and I'm looking to find an angle, and also I have a right angled triangle. So what's kind of springing to mind here is the use of trigonometry. So if I were to label these sides up, kind of linking to this angle here, this side CB is going to be the side that's adjacent to this angle, as it isn't the hypotenuse, so this is going to be the adjacent. And then AB is the hypotenuse of the triangle, so I can label that as H. Now if I think of SOHCAHTOA, I have A and H, so Ka of the SOHCAHTOA, which means that I need to work with cos. So cos theta is equal to A over H, and this here is the angle theta that they're working with. And I can sub my values in, so cos theta is equal to the adjacent, which is 7 centimetres, over the hypotenuse, which is 11. So theta is the inverse cos of 7 over 11. And if we calculate that using our calculators, we get an answer of 50.4788 degrees. However, the question is asked for our answer to 1 decimal place, so I can round that to 50 point, and then here we have the 7, which means that the 4 is going to round up to 5 as 7 is greater than or equal to 5, so 50.5 is the final answer here. We'd get the first mark for kind of working with cos here, so the cos of theta is equal to 7 over 11, that gives us the first mark, and then the second marks for the correct final answer of 50.5 degrees. Now for the second part of the question, I'm told that the length of the side AB is reduced by 1 centimetre, the length of the side BC is still 7 centimetres, and the angle ABC is still 90 degrees. And we're asked whether the value of the cos of ABC will increase or decrease given a reason for our answer. So if I have a look at my triangle and label up the new side, so AB is the hypotenuse and that's been reduced by 1 centimetre, so 11 minus 1, this is now 10 centimetres. Now if I want to find cos of ABC again, I need to substitute that in, so cos of theta or cos of ABC is equal to the adjacent over the hypotenuse. Again, the adjacent is going to be the 7 and the hypotenuse has gone from 11 to now 10. So I now have 7 over 10. Now I need to determine whether this means it's increased or decreased. Before we had 7 over 11 for the value of cos of ABC. And if I have a look at these, we know that 7 over 10 is going to be greater than what we had before, which was 7 over 11. So therefore, cos of ABC has increased due to this change. So we just had to do kind of a small calculation here, comparing our result to what we had before to get the mark for this part of the question. So in this question, we're told that there are some counters in a bag and that the counters are red, white, blue or yellow. We're told that Bob is going to take a random counter from the bag, and we're given a table which shows each of the probabilities that the counter will be blue or yellow. So we have in the first row the colour, so red, white, blue or yellow, and the second row the probability of the counter being that colour. Red and white aren't filled in yet. Blue is 0.45 and yellow is 0.25. We're told that there are 18 blue counters in the bag and that the probability that the counter Bob takes will be red is twice the probability that the counter will be white. And we're asked to use all of this information to work out the number of red counters in the bag. So initially here, if we want to find the number of red counters, we need to find the probability that the counter is going to be red in order to work with this and the total number of counters, which we can also calculate. So if I have a look at the information that we have, we're told that the probability the counter is red is twice the probability that the counter is white. So we could kind of fill this in. If the probability of a counter being white is x, the probability of it being red is 2x. Now, the counter that's picked has to be either red, white, blue or yellow, so all of their probabilities need to sum to 1 because they're the total, they're all of the things that can happen. Nothing else can happen if a counter's picked. So therefore, we know that 2x plus x plus 0.45 plus 0.25 is equal to 1. And if we add these x's together, we get 3x is equal to 1 minus 0.45 minus 0.25. And that gives us an answer of 0.3. So we now know that x is 0.3 divided by 3, so 0.1. And the probability of the counter being red is 2x, so 2x is equal to the probability of the counter being red is equal to 2 times 0.1, so 0.2. So we now have the probability that the counter is red. If there are 18 blue counters in the bag, we also have the probability that the counter is blue. So the probability that the counter is blue is 0.45, and that is equal to 18. So there are 18 blue counters. Now we can work out the total number of counters if we kind of take this as a fraction. So 0.45 lots of the total is equal to 18 counters. So if we let little t be the total number of counters in the bag, 0.45 multiplied by this gives us 18 counters, so those are 18 blue counters. So if we divide both sides by 0.45, we can take 18 divided by 0.45 to get us the total number of counters being equal to 40. And now if the probability of choosing a red counter is 0.2, we can simply multiply this by the total. So 0.2 multiplied by 40, as there's a 0.2, there's a probability of 0.2 of picking a red counter, and there are 40 counters to choose from. And 0.2 multiplied by 40 here gives us an answer of 8. So there are 8 red counters in the bag. Now, as for how each of the marks are awarded in this question, we would gain a first mark for finding the sum, for a process to find the sum of the unknown probabilities. So for finding the 0.3 here. The second mark is for finding the probability of the red counter or a white counter being chosen. So this 0.2 here we calculated. The third mark is for a complete sort of process calculation to find the number of red counters. So there's a multiplication by either finding the total or something similar here. And then the correct final answer of 8 gains us the fourth and final mark for this question. So now for the second part of the question here, we're told that a marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5. And we're told that there must be an even number of marbles in the box and asked to explain why this must be the case. So the probability that this marble is silver is 0.5 or a half. So that basically means that half of the marbles are going to be silver marbles and half are not silver. And if half of the marbles are silver, half of the number of the total marbles needs to be a whole number, as we can't have half a marble. So this is where the even or odd comes into play. So if we're to half an odd number, it's never going to give us a whole number. So for half a number to be an integer, that number, the original number, must be even, and you can't have half a marble. So this means that there must be an even number of marbles in the box in order for this to work and for there to be able to be a probability of a half. So to get the mark here, I'm just simply going to write a half multiplied by an odd number will never be a whole number. And also, it's a good idea to add here, you cannot have half a marble. So you need a whole number of marbles in the box. You can't have half a marble, so you can't choose half of an odd set of numbers, as this will not give you a whole number, so this is not possible. So in this question, I'm simply asked to solve this expression, this equation that we have here. So I'm going to need to multiply out some terms and simplify it down in order to find the value of x that satisfies this equation. So when I'm working with something like this, I like to kind of see where it's easiest to start and what I can do in order to collect some terms together. So when I have a fraction, which I have over this side, I've got something divided by 2 here. Now it's going to make sense here if I start off by multiplying both sides by 2 in order to get rid of this kind of denominator that we have here. So if I multiply both sides by 2, I'm left with 5 minus x is equal to 2 lots of 2x minus 7. And I can then expand my brackets on the right hand side, so 5 minus x is equal to, and we can do this by multiplying the 2 by the 2x and the 2 by the minus 7. So 2 multiplied by 2x gives me 4x, and 2 multiplied by minus 7 is minus 14. Now this looks a lot easier and more friendly to work with in order to solve for x. So I kind of now want to get all of my x terms onto one side and all of my numerical values onto the other side so that I can calculate a value for x. So if I want to collect my x terms together, I have a negative x on this side, so if I were to add an x to this side, I would end up with just 5 left over. So I'm going to add on x to both sides of my expression, remembering that I have to do the same thing to both sides at all times, and that gives me 5 minus x plus x, so just 5 is equal to 4x minus 14 plus x, which gives me 5x minus 14. And now to take all of the numbers to one side and keep the x's on the other, I can add 14 to both sides, as I have this negative 14 here. So 5 plus 14 gives me 19 is equal to 5x. And then I just want to find the value of 1x, what one lot of x is worth, so I can then divide both sides by 5 to give me 19 over 5 is equal to 5x over 5, so just x. So the correct answer here is going to be that x is equal to 19 over 5, and that gains me that final mark here. So as for how the marks are awarded for this question, you're going to gain a mark for the first step, so kind of multiplying both sides by 2 gains us that mark here. There's going to then be a second mark for isolating terms in x, so getting all of the x's onto one side, taking them to the same sort of place here in this step, and then the final mark is for the correct final answer. So it can be simplified, it can be written as 3.8 or equivalent fractions. However, 19 over 5 will get us the mark here, along with anything sort of equivalent to it. So in this question, I'm told that ABCDE is a pentagon. We then have the diagram of the pentagon here. It's an irregular pentagon. We're told that angle BCD is equal to 2 times the angle ABC, and we're asked to work out the size of the angle BCD, showing all of our working. Now if I have a look at the diagram, we have a couple of angles already labelled up, so this angle here, and also this angle here is a right angle, so I'm just going to write on there that that's 90 degrees. I'm told here that angle BCD is equal to 2 times angle ABC. So if I were to kind of give these a name, I could label angle ABC up as X, for example, and then angle BCD is 2 lots of angle ABC, so this is going to be 2x. So then I can just label them up on the diagram. So if I look for BCD, this angle here is going to be 2x, and the angle ABC is going to be equal to x. So now I have all of the interior angles labelled up in my pentagon. Now, working with this, I need to kind of set up some form of an equation with the interior angles and their sum. So if I think back to possibly a formula that I could use, I could think about the sum of the interior angles of a pentagon. It doesn't have to be a regular pentagon to use this. And to find the interior angle sum, I'm just going to use the formula 180 lots of n minus 2. That gives me the sum of the interior angles, where n is the number of sides of the shape. So we have 180 lots of n minus 2, and n, this is a pentagon, so it has 5 sides minus 2. So 180 times 3 gives me 540 degrees for the sum of the interior angles. And then I can simply write this up into some kind of equation. So if I sum together all of the interior angles, so 115 plus 125 plus 90 plus 2x plus x, that's going to give me an answer of 540. Now if I add together my x terms on this side and then subtract all of my numerical values from the left hand side and the right hand side, we end up with 540 minus 115 minus 125 minus 90, and that gives us an answer of 210. And then I can find the size of angle x by dividing both sides of this by 3, and that gives me x as being 70 degrees. However, we've been asked to find the size of the angle BCD, so this angle here, which is 2x. So I need to take 2x, which is 70, multiplied by 2 to get 140, which is the correct final answer for the size of angle BCD. Now, as for how each of the marks are awarded here, you would get the first mark for the process to find the interior sum of the angles of a pentagon, so this kind of working out step here. The second mark is for the correct answer of 540. Similarly here, you could use the sum of the exterior angles and work that way round, but I feel like this way is just a bit more quicker and easier to get to the final answer. The third mark is for a process to start finding the angle ABC, so for summing together all of these and setting up the equation here. And then another mark is going to be for further process to find this angle, so for having this line here of 3x being equal to 210. And then the final mark is going to be for the final correct answer here of 140 degrees for this question. Now, as long as we kind of work through it step by step, logically, through the whole question, then we make sure to cover all of the points and we use all of the information in the question, then we'll make sure to pick up all of the marks here along the way. So in this question, we're given an expression for t, showing that t is equal to the square root of w over d cubed. And just to make this a little bit clearer, we can put brackets around the w over d cubed to show that we're finding the square root of the whole thing here. So we're finding the square root of everything that's inside the brackets. We're given the values for w and d. So w is equal to 5.6 times 10 to the minus 5, and d is equal to 1.4 times 10 to the minus 4. And we're asked to use this information to work out the value of t, given our answer in standard form, and correct to 3 significant figures. So if we want to give our answer in standard form, we already have these values here for w and d. These are in standard form. So standard form is when you've got a number here before the multiply sign, which is greater than or equal to 1 and less than 10. So it can't be 10, it has to be between 1 and 10, less than 10. So what we can do is take the expression for t and substitute in the values that we have for w and d. So t is equal to the square root of w, which is 5.6 times 10 to the minus 5, divided by d cubed, which is 1.4 times 10 to the minus 4, all cubed, and all of that is going to be under the square root sign. We need to make sure that we cube the whole of this value here. So by putting that in brackets, that makes sure that we do cube the whole value. So you can then substitute what we've written out here into the calculator, and that will come out with a value of 4,517.5395, etc. So it's really important to make sure you type this into your calculator correctly, having all of this expression underneath the square root sign and making sure you cube the whole of this value here. So that comes out with this value, and we need this correct to 3 significant figures and in standard form. So firstly, we can convert it into 3 significant figures, so we're going to have to do some rounding. So this would be the first, the second and the third. So we're here with the 1, and to the right of this we have a 7, and the 7 is greater than or equal to 5, so that means we're going to round this 1 up to a 2. So that leaves us with 4,520 to 3 significant figures. Now we can put this into standard form. So again, we need a number between 1 and 10 basically. So we can take it down to 4.52, which is between 1 and 10, times 10 to the power of some value. And if we look here, if we were to pop the decimal point in here, we'd have to move it 1, 2, 3 places to the right to raise it to raise the value of 4.52 to 4,520. So we've had to move the decimal point 3 places, so we've had to multiply it by 10 to the power of 3. So 4.52 times 10 to the power of 3 is going to be the correct answer for t to 3 significant figures and in standard form. So you get the first mark here for this correct unrounded value of t. Alternatively, you could get the first mark for finding the value of w divided by d cubed. However, I've kind of done it all in one step and taken the square root at the same time just to make sure we don't get any kind of rounding errors or anything while we're calculating the value. And then the second mark is for the correct final answer of 4.52 times 10 to the 3. So now in this part of the question, we're told that w is increased by 10%, and that d is increased by 5%. We're told that Lottie says the value of t will increase because both w and d are increased. Lottie is wrong, and we're asked to explain why. So here we're working with these new values of w and d. So we're looking at new values, and we want to use these new values to see whether the value of t that these values produce is greater than or less than the previous value of t that we calculated. So one way we can do this is by looking at the scale factors by which w and d are multiplied in order to get the new values of w and d. So if w is increased by 10%, that's the same as multiplying the original value of w by 1.1. So it's a scale factor of 1.1 gives us the new value of w. Similarly, for d is increased by 5%, that's the same as multiplying by a scale factor of 1.05. So this 0.05 gives us the 5% increase, the 5%, and then the 1 shows that we're taking that from the original value. So we're taking all of the original value and adding on 5% of it. So we're told that Lottie says the value of t will increase, so we need to see if this is actually the case. So we can do this by using the scale factors that we've calculated here. And instead of maybe going about the question in a bit of a longer way, we can simply substitute in the scale factors for w and d to get the scale factor by which t is multiplied to find the new value of t. So we can take the expression that we had before and take the square root of w, or the scale factor by which w is multiplied, so 1.1, and divide that by the scale factor by which d is multiplied, which is 1.05, but this has to be cubed because we have the d cubed here. And that gives us an answer of 0.974, etc. And we can now see that t is going to be multiplied by this scale factor of 0.974, 0.97 to get the new value of t. Now, noticing here, 0.97 is less than 1, so if we multiply a value by a value which is less than 1, it's actually going to, the new value produced is going to be less than the original one. So the new value of t is going to be less than the original because the scale factor is less than 1. This contradicts this statement here, that t will increase, because in fact it will decrease. So to put that into words, if we say that the value of the scale factor, which we've calculated for t, is less than 1 in this instance, so there must be a decrease in t, as multiplying any value by a value less than 1, this value of 0.97, is going to give us a decrease in the original value. Alternatively, we could have gone about this by taking the original value for w and d and multiplying them by their scale factors and then substituting them in to find the actual value of t once these increases in w and d have been made. And you'd then get a value for t of 4.4 times 10 to the 3, which you can see is less than the original value that was calculated for t, which was 4.52 times 10 to the 3. So you can see that t is decreased. So the marks here, the first one would be for calculating this value of the scale factor, and then the second mark is just for justifying that with a few words at the end. So in this question, we have 3 lamps, A, B and C. We're told that lamp A flashes every 20 seconds, lamp B is every 45, and lamp C is every 120. We're told that the 3 lamps start flashing at the same time, and we're asked how many times in 1 hour will the 3 lamps flash at the same time. So we're given quite a lot of information here that we're going to work with, but once we have a look through the question and realise what it's actually asking us, it seems a lot more easy to approach and to find a tactic to kind of attack the question with. So if we want to work out how many times they'll flash at the same time, it could be useful to work out how often they're going to flash at the same time. So after how many seconds will they flash all at the same time? Now, something here that is initially quite apparent to me is that we have lamp A and lamp C. Now, if lamp C flashes every 120 seconds, every time lamp C flashes, lamp A is also going to flash. Because lamp A flashes every 20 seconds, 120 is a multiple of 20. So if lamp A is flashing every 20 seconds, it's going to flash at 120 seconds, at 240 seconds, etc. So whenever lamp C flashes, lamp A also flashes. So really here, we just need to look at the relationship between lamp B and C. So when are these two going to flash at the same time? Now, thinking again about the multiples and factors sort of idea, we can work out when they're going to flash at the same time by finding the lowest common multiple of 45 seconds and 120 seconds, and that's going to give us the shortest amount of time that has to pass from the start before the two flash at the same time. So here we can work out the lowest common multiple of 45 and 120, and the way that I like to do that is by kind of creating a prime factorisation tree for each number. So if we take 120 and split it into its prime factors, I know it's divisible by 2, which is prime. 2 times 60 gives 120. Now 60 we can split into factors of 2 and 30. 2 times 30 is 60. And again, divisible by 2, which is prime. And 15. Now 15 isn't divisible by 2, but it is divisible by 3. And 3 times 5, and 5 is also prime. So we've split 120 into its prime factors. And we can write that out as 120 is equal to 2 times 2 times 2 times 3 times 5. We then have 45, which I can split into its prime factors again. This time it's not divisible by 2, but I can see that it will be by 5. So I'll split that into 5. And then 45 divided by 5 is 9, so 5 and 9. And then 9 is divisible by 3 and 3. So the prime factors of 45, the prime factorisation is 3 times 3 times 5. Now, in order to find the lowest common multiple, I often like to draw out a Venn diagram just to work with these numbers. It often makes it just easier to see what we have going on. So we can draw out a quick Venn diagram. Now if we have 120 here, 45 here, we're just going to put in the prime factors. So any that go in the intersection, so in this section here, are prime factors of both 120 and 45. And we have 3 in both and a 5 in both. So in the centre, we're going to have 3 and 5. And then in the rest of the 120, we'll have 2, 2, and 2. And then over here, we'll have a 3. Now we can work out the lowest common multiple by multiplying together all of the factors in the Venn diagram. So in this instance, because the 3 and 5 are only counted once, not twice, as they would be if we were just simply multiplying 120 and 45, multiplying all of the factors together, they're only counted once in the Venn diagram, and that is why we get the lowest common multiple, because we've taken out the duplicated repeat factors. So we can multiply all of those together, so we get 2 times 2 times 2 times 3 times 5 times 3, and that gives us an answer of 360. So every 360 seconds, the lamps B and C are going to flash at the same time, and we know that A will also flash because A flashes every time that C flashes, and also if A flashes every 20 seconds, 20 is a factor of 360. So 360 is a multiple of 20, so A will also flash at the same time. Now we're asked how many times in 1 hour they'll flash at the same time. So if we convert 1 hour into seconds, 1 hour is 60 minutes, and in a minute there are 60 seconds, so 60 times 60 is equal to 3,600 seconds. So there's 3,600 seconds in a minute, and if they flash every 360 seconds, we can find the number of times that they're going to flash by using the lowest common multiple and taking 3,600 and dividing it by 360 to find that they flash 10 times. So A, B and C will flash all at the same time 10 times within a 1 hour period. So within a 3,600 second period, they'll flash 10 times at the same time. And that brings us to the end of the question. So the first mark here would be for starting a process to find the lowest common multiple of the 3 values that we have. So if you've written out some prime factorizations or multiples of 45 and 120, you would get the first mark here. The second mark is for a process to find the number of times using the lowest common multiple. So this part here, 3,600 divided by 360. So you're using the lowest common multiple value that you've calculated and taking the number of seconds in an hour and dividing it by the lowest common multiple. And then the final mark is for the correct answer here of 10, and that gets you your third and final mark for this question. So in this question, we're told that in 2003, Jerry bought a house. In 2007, Jerry sold the house to Mia, and he made a profit of 20%. We're then told that in 2012, Mia sold the house for £162,000, and she made a loss of 10% on what she'd paid for it. We're asked to work out how much Jerry paid for the house in 2003, which is in the first line of the question up here. We're told that he bought the house. So this is where we need to get back to. So if we need to work back to the start of the question, we're given a lot of information, so it's going to be useful to find a way and a tactic to approach this question by breaking it down a little bit. And we need to get back to the start to work out how much he bought the house for. So we're going to be working backwards through the question and through the information. So if we focus on this last part first, we've got the most information here because we've got an actual price and we've got the loss that Mia made. So we can use this to kind of start working backwards through the information. So if in 2012 Mia sold the house for £162,000, she made a loss of 10% when she did this. So we could take kind of a value M, being the price that Mia bought the house for. And she made a loss of 10% on this. So she sold it, making a loss of 10%. So if we were to kind of use a multiplier to express this, if she made a loss of 10%, that's 10% less than 100%. So it's like she sold it for 90% of value that she bought it for. So if we take M being the value that she bought it for and multiply this by a multiplier that's going to give us 90%, so 0.9, that takes us back to the price that she sold the house for, £162,000. So we can work out M from this information by doing 162,000 divided by 0.9. That's just rearranging what we have here and dividing both sides by 0.9. So M is going to be £180,000. So we've worked out how much Mia bought the house for. And if we go back to this line, Jerry sold the house to Mia for this amount. So Jerry sold the house to Mia for the price that Mia bought it for, so £180,000. And Jerry made a profit of 20%. So we can set up a similar equation. So if I use this time J for the price that Jerry bought the house for, the price that he bought the house for, times some multiplier here is going to give us the price that he sold it for, which is 180,000 to Mia. Now he made a profit of 20%, so this multiplier that we need to put in this gap here is going to be 20% more than 100% in a sense. So that multiplier is going to be 1.2. So the amount that he bought it for times 1.2, because he made a profit of 20%, gives us the amount that he sold it for to Mia, which is 180,000. So J is equal to 180,000 divided by 1.2, and that gives us an answer of 150,000. And J was the original amount that Jerry bought the home for, because that's what we kind of assigned the variable to be. So in that case, we've come to the correct final answer, and we know that Jerry paid £150,000 for the house. Now, as for the marks, how the marks are awarded here, the first mark is for a process to find the cost in 2007. So for coming to this answer here of 180,000. The second mark is for then continuing on and using a process to find the cost in 2003. So the line here, 180,000 divided by 1.2. Or alternatively, if you'd have got the first part wrong, so if you hadn't have found this value of 180,000, just by subbing in the value and dividing it by 1.2, you would pick up a mark here. And then the answer mark for this question is for the correct final answer of £150,000. So in this question, we're told that the graph shows the volume of liquid, L litres, in a container at T seconds. And we can have a look at the graph and we can see that on the y-axis we do have volume in litres, and on the x-axis we've got the time in T seconds. So we're asked to look at this graph and then find its gradient. So to find the gradient of the graph, we're going to look at the change in y value, so the change in volume, divided by the change in the x value, so the change in time. So if we write that out, so m, which is often used to describe the gradient, is equal to delta y, delta being change in, over delta x. So then a good way to do this is to draw out a big triangle on the graph so that we can work out easily, we can see easily the change in y and the change in x. So if I'm going to start at this point here, come down to here, and then we can do the same along the x-axis. this is going to be the change in y, and this is going to be the change in x, these distances. So the change in y is going to be equal to the y value at the top here minus the y value at the bottom here. So if we go along the line, the y value at the top is 16 and then at the bottom it's 4. So the change in y is 16 minus 4, which is equal to 12. And then similarly for the change in x value, x at this furthest point is 8, and then x at this point here is going to be 0. So we have 8 minus 0 is equal to 8. So m is equal to change in y with change in x. So we have 12 divided by 8, and that gives us an answer of 1.5. And you'll get the first mark here for using a process to find the gradient of the line, so using a method to find the gradient. And then the second mark is going to be an answer mark for the correct final answer of 1.5. So now for this part of the question, we're asked to explain what this gradient represents. Now I'm going to refer back to what we did in part A here. So instead of using numbers to calculate the gradient, we're looking for a more qualitative response. So we're using words and the context of the question to explain what the gradient represents in this part of the question. But again, I can use a similar approach to that in part A. So the gradient is equal to the change in y divided by the change in x, and we use that in part A. However, this time, instead of using numbers, I can just look at the words and the context. So the change in y is the change in volume of liquid in the container. Or if we want to look a little bit more closely, it's the change in the number of litres. And that's going to be divided by the change in x, so divided by the change in time or the change in the number of seconds. Now one way, quite an efficient way of writing this out, is going to be by taking the change in the number of litres, so the change in y, and we're dividing that by the number of seconds that passes, or I could write this as per second, because that's still going to represent the gradient. So for every second that passes, how do the number of litres in the tank change? And that gets us an expression for the gradient in terms of words with the context of the question. So alternatively here, because we have a value per second, we could use the word rate and say the rate at which the container fills. Or we'd still get the mark for saying something like the number of litres added per second, as long as it's an explanation relating to the rate of change of volume with time. Now for the final part of the question, we're told that the graph intersects the volume axis at L equals 4, and again we're asked to explain what this intercept represents. So if I just have a look at the graph, we can see here that it intersects the volume axis, so the y-axis, at L equals 4, and that is going to be the volume when the time is equal to 0. So when x is equal to 0, y equals 4, so when the time is equal to 0, the volume is 4 litres. And that's really all we need to know and write down to get the mark here. So you need an explanation relating to the volume of liquid in the container at the start of this kind of experiment that's going on here. So to get the mark here, I'd simply write the number of litres in the container. So we're referring back to the context of the question. We know that it's in a container when t equals 0. Or alternatively, you could say the amount of liquid in the container to start with, or the initial amount of liquid in the container. Any of these ways of phrasing it will get you the mark for this question. So in this question, we have two similar solid shapes, and we're told that the ratio of the surface area of shape A to the surface area of shape B is 3:4. And we can see that shape B obviously does look larger than shape A, so that would make sense. And we're told that the volume of shape B is 10 centimetres cubed. We're asked to work out the volume of shape A, given our answer correct to 3 significant figures. So here we have the ratio of the areas, the surface areas of the shape. And we want to work out the ratio between the volumes of the shape to work out the volume of A. So the way that we could do this is by working out kind of the linear relationship. So the scale factor of the lengths between the two shapes. So length multiplied by length is going to get us area. So if we want to work out the ratio between the lengths of the two shapes, what we can do is square root both sides of this ratio. So if we have the area, surface area ratio is 3 to 4, then we need to use a method to find the ratio or the scale factor of the lengths. So the length ratio here, length is going to be the square root of the area in this instance, so we can have root 3 to root 4. So root 3 to 2, because the square root of 4 is 2. Now, to get this in a bit more of a form that's a little bit easier to work with, we can divide both sides by root 3. So 1 to 2 divided by root 3, that gives us 1.1547, etc. Now, what we can do with this, we need to work out the ratio between the volumes. So the volume ratio here, now volume is going to be the length cubed. So we can now cube both sides of this ratio. So we can cube 1, which just gives us 1, and then if we cube 1.1547, or the exact value which I left in my calculator, that's going to give us 1.5396. And we can then take this value, and we know that we have 1, so this is going to be A to B, the volume ratio. We know that the volume of B is 10. So if we change this into a ratio x to 10, where x is the volume of shape A, then in order to work out what x is, we can simply take this 10 and divide it by 1.5396. And that's going to tell us the factor by which we must multiply the 1 of A by to get up to x. And because we're multiplying it by 1, this is just going to give us x. So the factor required to jump from this value to 10 is just given by 10 divided by that value, and that's going to be the same as what we multiply 1 by to get to x. And that value is going to be 6.495, etc. So just going back to this part here, to get from 1.5396 to 10, we're going to multiply by 6.495. So to get from 1 to x, we need to do the same thing to both sides, so multiply by 6.495. So the value of x here, which is the volume of A, is going to be 6.495, and it wants the answer correct to 3 significant figures, so 6.495 rounded to 3 significant figures, 1, 2, 3. To the right of the 9 is a 5, and that's greater than or equal to 5. So we're going to round the 9 up, however that takes us to 10, which then means we need to round the 4 up to a 5. So that just leaves us with 6.50 to 3 significant figures. Now the marks here, the first mark is awarded for the method to find the ratio between the lengths. So here. The second mark is for finding the ratio between the volumes. And then the third mark is for the correct final answer of 6.50, or an answer in the range of 6.49 to 6.53, just depending on how the answers have been rounded and kind of how the answers have been manipulated and rounded throughout the question it might just give a slight fluctuation in possible answers at the end there. So in this question, we're told that there are 16 hockey teams in the league and that each team played 2 matches against each of the other teams. We're asked to work out the total number of matches played. Now, in this question, we can look at the number of hockey teams. So we have 16 hockey teams in a league. And if each hockey team were to play every other team once, it would play 15 matches because it can't play against itself. So there's 15 other matches, 15 other teams it could play against. However, we're told that each team played 2 matches against each of the other teams. So A would play against B, for example, twice. However, what we need to be careful of here is that A playing against B is the same thing as B playing against A. So although each team is playing 2 matches against each of the other teams, these are all going to be counted twice because A playing B is the same as B playing A. So it's counted when looking at the teams that A is playing and when looking at the teams when B is playing. So we're actually going to need to half the number that we think it's going to be, basically. So if we have 16 hockey teams in a league and they're each playing 2 matches against each of the other teams, then that would kind of look like we're going to have 16 hockey teams playing 15 other teams twice. However, we then need to divide this value by 2 because A playing B is the same as B playing A, so we're going to have double the amount of outcomes that we actually need. So in order to get the actual answer to this question, we simply need to do 16 multiplied by 15, and that gives us an answer of 240. So we don't need to multiply by that 2 because each team playing 2 matches against each of the other teams could kind of be simplified as saying one of those matches is shown by A playing B and one of them is shown by B playing A. Although they're the same thing, we can just speak about them the other way round to kind of differentiate between them, and that means that each team is playing 15 separate matches against other teams and there's no overlap within that, so it is 16 times 15. So the correct final answer is 240, and we're going to get a mark for that and then a mark for the process, so for using the 16 multiplied by 15 to get the 240. It gives us that second mark here. So in this question here, we have a graph which shows the speed of a car in meters per second during the first 20 seconds of a journey. And we can see the graph here. So we have speed in meters per second on the y-axis and then time in seconds on the x-axis. And we're asked to work out an estimate for the distance travelled by the car in the first 20 seconds of motion. And to do this, we're asked to use 4 strips of equal width. So looking at the graph, we have a graph of speed against time, and we're looking to find distance. Now, if I think about the formula, distance is going to be equal to speed times by time, multiplied by time. So if we have speed on the y-axis, time on the x-axis, if we multiply them together, we're actually finding the area of the graph. So the distance is going to be the area underneath the line, underneath the curve. And we're asked to use 4 strips of equal width to calculate this. So if the maximum time is 20 seconds, we can divide this by 4 to get the strip width that we're going to use. So the width of the strip is going to be 5. So we can split this into strips of width 5. So starting at 5 seconds and then one at 10 seconds, one at 15, and then the final at 20. Now we can remember here that this is just an estimate, so we're not looking for the exact value. The lines aren't going to quite perfectly match up with the curve, so we can kind of approximate these as would commonly use trapezia to do this. So for example, over here, if we were to connect these two up, we're pretty much going to stay on the line. So that would create a trapezium here. And again, at this point, another trapezium and another one here. And then finally here, if we were to make a trapezium, this side would have no length as it goes through the point 0, 0. So here we're just simply going to connect that point to this point and make it into a triangle. Now obviously there is quite a lot of area here which is left unaccounted for, but this is okay. We're just looking to calculate an estimate. So we appreciate that this isn't going to be an accurate value, it's just a rough idea. So we can now estimate the distance the car travelled by adding up the areas of each of these shapes that we've created. So this triangle and then these three trapezia. So we can calculate the area. So here, the area of this triangle, half the base times the height. So we have a half multiplied by the base, which is the width, so 5, multiplied by the height here, which is 22. So a half times 5 times 22 gives us the area of the triangle, and that's going to be 55. And then here, the trapezium, the first one, the area of a trapezium is half the sum of the parallel sides times the height between them. It's a handy little rhyme. So we can do the sum of the parallel sides, so these two sides are the parallel sides, and this one is 22, and this one here is 28. So we can find half of the sum of the parallel sides, so 22 plus 28, times the height between them, which is the width of the bar, so 5. And that's the area of this trapezium, which is going to give us 125. We can then do this one as well using the same formula. So half the sum of the parallel sides, this time we have 28 and 32. So a half times 28 plus 32 times 5, again, which is the height between them. And then finally here, half the sum of 28 plus, 32 plus 35. So we can just take that as being 32 plus 35 times the height between them, which is just 5 again. And just quickly putting the totals in here, that one would be 150, and then this one is going to be 167.5. Now, estimating the distance, we just need to find the sum of all of these strips that we've calculated. So 55 plus 125 plus 150 plus 167.5 is going to give us a final answer of what we have here, which is going to be, if we just put that into the calculator, 55 plus 125 plus 150 plus 167.5 gives us 497.5. So as for how the marks are awarded here, you get the first mark for using a method to find the area of one strip using trapezia. So one of these will get us the first mark. The second mark is for a complete correct method to find the area using all 4 of the strips. So using all 4 of them. And then the third and final mark is for an answer in the range of 488 to 507. There's a little bit of leeway just to account for kind of different readings of being taken from using the strips and that kind of thing. Answers may differ slightly. You could also use rectangles to estimate the area, and that's going to give you different values still. Now for part B of this question, we're asked whether the answer to part A is an underestimate or an overestimate of the actual distance the car travelled in the first 20 seconds. And we're asked to give a reason for this answer. So thinking back to the first part of the question, I did touch upon the idea that the answer isn't going to be entirely accurate. It is an estimate, and that's because some of the area below the graph isn't included. So all of the trapezia and the triangle in particular means that there is area under the graph, under the line, that isn't going to be included when we're calculating the area of these shapes. So as there's area that's not included, it's going to be an underestimate because the distance should actually be greater, more squares should have been counted, but because we were approximating it with triangles and trapezia that were smaller than the area, it is in fact going to be an underestimate. So to get the marks here, I'm just going to put underestimate. We're stating that it is an underestimate, and that's going to be since parts are not included below the graph. It might make sense to put the word some in here, so some parts are not included below the graph when they should be to get the accurate distance, so therefore it's an underestimate because not all of the area has been taken into account. So that gets us the mark here. We have to make sure that we state it is an underestimate and then go on to explain why. So in this question, we're told that the nth term of a sequence is given by the expression an squared plus bn, where a and b are integers. We are also told that the second term of the sequence is minus 2, and that the fourth term of the sequence is 12, and we need to use this information to find the sixth term of the sequence. So we know what form the sequence is of, we've got the form here, but then we have the two unknowns, a and b. So in order to find the sixth term of the sequence, we can calculate and work out what the unknowns are, the integers a and b. We can find these integers, and then we can substitute in n is equal to 6 to find the sixth term of the sequence. So we have the second and fourth terms, so we can substitute these values in as well to work out the values of a and b, and we can solve a couple of equations simultaneously once we've put them together. So if we start with the first one, we know that the second term of the sequence is minus 2, and we could kind of use a bit of notation here and just call the second term u2. So un is just the general term, the nth term of the sequence. u2 is going to be the second term. And we know that has to be of the form an squared plus bn. So un is equal to an squared plus bn. However, u2 is when n is equal to 2. So we can substitute 2 in for n. So substitute 2 in here and 2 in here. We end up with a multiplied by 2 squared plus b multiplied by 2. And these are separate here. And then we can simplify that. So 2 squared is 4. So it's going to be 4 multiplied by a, so 4a plus b multiplied by 2, which is 2b. So u2 is equal to 4a plus 2b, but we also know that u2, because it's the second term of the sequence, is minus 2. So we can equate that expression here to minus 2. And then we can do the same over here with u4 is equal to a multiplied by n squared, which n is in this case 4, so a times 4 squared, plus b times n, which is 4, so b times 4, so that's going to be 4 squared, which is 16 times a, plus 4b, and this time u4 is equal to 12. We have that equal to 12. Now we kind of have these two separate equations here. So we have 4a plus 2b is equal to minus 2. We can call that equation 1. And then we have 16a plus 4b is equal to 12, and we'll call that equation 2. And in order to solve these for the values of a and b, we can solve them simultaneously. So we want to eliminate one of the variables, and we do that by basically scaling one of them up or down so that we have the same number of either a's or b's in each equation. So here I can quite easily see that if we've got 2b in this equation, we could simply multiply this whole equation, so both sides of the equation 1, by 2, and then we'd have 4b, which we have over here as 4b. So then we can cancel out the 4b's and solve the equation simultaneously. So if we basically double the expression, double equation 1 here, we end up with 8a plus 4b is equal to minus 4. So I've multiplied the 4a by 2, the 2b by 2, and the minus 2 by 2. So we multiplied everything on either side of the equation by 2. And we now have this new equation here and equation 2. And we can use this. So if we call this one equation 3, we can do equation 3. Actually, if we do equation 2, subtract equation 3, the 4b's are going to cancel out, leaving us with just the values of a and some numbers, so we'll be able to solve this for a. So if we take equation 2, which is 16a plus 4b equals 12, and just right below it equation 3, which is 8a plus 4b is equal to minus 4, we can then subtract the bottom one from the top one. So we can do 16a minus 8a, and that gives us 8a down here. And then we can do 4b minus 4b, which just gives us 0. And then on the right hand side, we have 12 minus minus 4, which is going to be the same as 12 plus 4, because we're subtracting a negative. So 12 plus 4 is 16. So we have 8a is equal to 16. And if we divide both sides by 8, a is equal to 2. And then we can just substitute this value for a back into an equation. So if I take this back into equation 1, for example, we could have 4a plus 2b is equal to minus 2. So 4 times the value of a, which we just calculated to be 2, plus 2b is equal to minus 2. So 8 plus 2b is equal to minus 2. We can subtract 8 from both sides to get 2b is equal to minus 2 minus 8, so minus 10. Divide both sides by 2, and we have b is equal to minus 5. So we've now used this information and solved these equations simultaneously and have found values for a and b. So we now have this kind of nth term of the sequence, and I'll just write that out. So un is equal to an squared, so 2n squared, plus bn, where b is minus 5, so minus 5n. Now we want the sixth term of the sequence, and that is going to be the term when n is equal to 6. So u6, that's when n is equal to 6. So we have 2 times 6 squared minus 5 times 6, and we can just put brackets around those. So that's 2 times 36 minus 30, and that takes us to 72 minus 30, which gives us an answer of 42 here. Now, as for how the marks are awarded for this question, the first marks for a process to find an equation in A and B. So for finding one of these original equations here, for example, by substituting in the value of u2 or u4. Second mark is for a process to solve the simultaneous equations, which we've done here. The third mark is for the correct values of a and b of 2 and minus 5. And then the fourth and final mark is just for the correct final answer here of 42. So now in this part of the question, we are given the first 5 terms of a different quadratic sequence, and the terms are 0, 2, 6, 12 and 20, and we're asked to find an expression in terms of n for the nth term of this sequence. So again, we're told that this sequence is also a quadratic sequence, so the nth term we could just write out a general form just so we have a general idea of what we're looking for. So similarly to the first one, un, so the nth term of the quadratic sequence, is going to be of the form an squared plus bn plus c, and this n squared is really important because that's what makes it the quadratic sequence. So this is kind of a general formula for a quadratic equation anyway. So that's where that comes from. Now to find these values of a, b and c, and therefore find the nth term of the sequence, we need to go back and use a method to work through the question and find the relationship between the terms. So if I just write out the terms again, 0, 2, 6, 12 and 20, to find the coefficient of n squared, so a in this case, we need to look at the second difference between these terms, and this is just kind of the method that you have to know and use to find this. So the difference between 0 and 2 is plus 2, between 2 and 6 is plus 4, between 6 and 12 is plus 6, and between 12 and 20 is plus 8. And that's the first difference. As we can see, it's not constant, so the nth term must be of a quadratic form, because not a constant common first difference. But if we then look at the second difference here, the difference between 2 and 4, we're adding on 2. Between 4 and 6, we're adding on 2 again, and between 6 and 8, we're adding on 2 again. So we now have a constant difference. We can use this to find the value for a in this instance, and what we do is take the second difference and divide it by 2. So 2 divided by 2 is going to be equal to 1, so a is equal to 1 in this instance. We now just need to find the kind of value of b and c, so the bn plus c part, and for this bit we can just solve it as it was we can kind of manipulate it beforehand and then solve it as so it's a linear sequence that we have here. So what we need to do is subtract one lot, because there's one lot of n squared because a is 1, so we subtract one lot of n squared from the original sequence that we have here. So I can write it out again, 0, 2, 6, 12, 20, and then we have another column here, so n squared. If I just write that here, so at this point n is 1, so 1 squared is 1, and then 2, so 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So now we need to subtract the n squared part from the original sequence that we have here, so from each term. So when n is equal to 1, we need to take 0 and subtract the 1. So I'm just going to write that out below. So 0 minus 1 is minus 1, 2 minus 4, minus 2, minus 3, minus 4, and minus 5. And now the method that I like to use is the dyno method, and we can just find an equation for this linear sequence that we have here. So using the dyno method, we first need to find the difference. So the di part of dyno stands for the difference, and if we look, we're subtracting 1. Moving from one term to the next, we're subtracting 1 each time. So the difference is equal to minus 1. And how the dyno method works is di and then no. So we take the difference, which is minus 1, put an n after it, and then we're going to add on the 0th term. So this here is the first term of this sequence, and if we're subtracting 1 when we're going this way, to the second, third, fourth term, if we want to go back to the 0th term, we're going to add on 1. So we're going to take the minus 1, which is the first term, add on 1, and that just gets us 0. So actually, this is just going to give us minus 1n, which is minus n, plus 0, so this last part is just minus n. And then we need to remember to add on the original value. So we had a is equal to 1, so we've got 1 lot of n squared. What we've worked out here is that the coefficient of n is minus 1, so b is minus 1, so we need to subtract n, and then c was 0, because the minus 1 and plus 1 cancelled out. So as for how the marks are awarded for this question, you're going to get the first mark for a kind of correct general method. if you come to the conclusion that n squared is going to be a term on its own here, so that a equals 1, you'll get the mark for that. And then the second mark is for the correct final answer that we have here. So for this question here, we have this diagram at the top here, and we're asked to work out the length of the side AD, given our answer correct to 3 significant figures. So AD is this side over here, and I'm just going to label that up. I'm going to leave it being called AD, but I'm just going to label that up so that we know that that is the side that we're looking to find. Now looking at this diagram, it seems as though it consists of 2 triangles. So we have the triangle ADB and the triangle DBC here. And they have this side BD in common, so they share this side BD. So that shared side is probably going to become quite important later on in the question. So I'm just going to label that up as well, just as BD. Now if we want to find AD, that's a part of this triangle that we have over here. However, we don't have much information about it. We just have one side length and one angle. So if we were able to find another angle or another side length, this would be really helpful for this question, for answering this question and finding AD. So if we were able to find the length BD, we'd then be able to use this information to find the length AD. So finding BD, because it's shared with this triangle over here, which we have more information about, we can calculate BD. And we have 2 angles in this triangle and 1 side length. So what we can use here to find BD is going to be the sine rule. And if we write out the sine rule in this form, it basically states that, so for some length, for some side length, divided by sine of the angle opposite that side length is equal to the side length of a different side of the triangle divided by sine of the angle opposite that length. So just to make that a little bit clearer, we can substitute in the values. So if we take firstly BD divided by sine of the angle opposite that side length, so the angle opposite this side is actually going to be this 34 degrees over here, because it's the angle that is opposite that side. So sine of 34. And that's going to be equal to B, so a different side length, so we can take this 12.5 because we know that, divided by sine of the angle opposite this length, so the angle opposite DC is this one over here, 109 degrees, so sine of 109. Therefore, if we want to calculate BD, we can just rearrange this equation by multiplying both sides of the equation by sine 34. So we have BD is equal to 12.5 over sine of 109 multiplied by sine 34. And if you put that into your calculator, that is going to give you an answer for BD of 7.39267, etc. But we can just leave it at 7.39, etc. But it's important just to keep the actual value, the unrounded value, in your calculators, just so we don't get any rounding error throughout the question. So I'm going to be using the unrounded value that I've got in my calculator here. But now we have the length of BD, so I can just label that up here, 7.39, etc. So now in this triangle, we have 2 side lengths and the angle between them, and we want to calculate the length of the side opposite this angle, which is AD. So now what I'm thinking is that to calculate AD, we can use the cosine rule. So the cosine rule, you can write it out in a lot of different forms, but we want to find the length of the side opposite the angle. So I'm just going to take this as a squared is equal to b squared plus c squared minus 2bc cos capital A, which is the angle between sides B and C. So now in this case, if I just label up the diagram at the top, we'll take AD as being A, and then these 2 sides can be B and C. Either way round, it doesn't matter. So what I'm going to do here is we have a squared, which is actually AD squared, is equal to b squared, and b is 11.4, plus c squared, and c was the length BD, which we had as 7.39, etc. squared. Then from that, we're going to subtract 2 lots of b times by c, which is the 7.39, times by cos of the angle between b and c, which is going to be 86 degrees. And then if we sub that into our calculators to find AD squared, we're going to get an answer here of 172.85, etc. That's using the non-rounded values. Then to find AD, we just square root both sides of the expression, so 172.85 square root of that, and that gives us the value of AD of 13.147, etc. However, it did ask us to give our answer to 3 significant figures, so rounding that to 3 significant figures, we're going to have 13 point, and then we need one more. So if we look to the right of the 1, it's a 4, which is less than 5, so we don't round the 1 up and we leave it as the 1 there. So 13.1 is the correct final answer. So now, as for how the marks are awarded here, the first mark's awarded for starting a process to find the length of BD, so setting up this equation that we have here. The second mark is for finding BD, so rearranging this and calculating the value of BD. The third mark's for a process to find the length of AD, so by using the cosine rule here. And then the fourth mark's for correctly using the correct order of operations to find AD squared, so making sure we've got all of the numbers substituted correctly and using the cosine rule correctly. And then the final mark is for an answer of 13.1 that we have here, which is rounded correct to 3 significant figures. So in this question here, we're asked to show that the equation x cubed plus x equals 7 has a solution between 1 and 2. So looking at the equation here, we're basically told that there is an x value between 1 and 2, which, if we substituted it into the left-hand side here, would give us the value of 7. What I'm going to do to begin with is just to maybe get this equation in a bit more of a more recognisable form, a form that's going to be easier to work with. So if we have x cubed plus x is equal to 7, if we were to subtract 7 from both sides, we'd be left with x cubed plus x minus 7 is equal to 7 minus 7, which is 0. So I'm moving the 7 onto the left-hand side by subtracting 7 from both sides. Now we've kind of got an equation that might look a bit more familiar. So we've kind of got an equation over here and we're setting it equal to 0. So if we're looking for a solution between 1 and 2, well, to show that there's a solution here, we need to show that this equation over here has a solution between 1 and 2 similarly. And the way that we can do that is by subbing in the values of x equals 1 and x equals 2, so the bounds here, and looking at the values that we get out and seeing what they are in comparison to this 0 that we're looking for, where the root is, where the solution is. So if we take x is equal to 1, substituting that into the left-hand side of this equation, 1 cubed plus 1 minus 7 is equal to 1 plus 1 minus 7, and that's going to give us minus 5. And then similarly with x equals 2, we have 2 cubed plus 2 minus 7. 2 cubed is 8 plus 2 minus 7, and that gives us 3. So we've got these values out when we sub in x equals 1 and x equals 2, and we just need to work out what they mean and what they show. So we're looking for a value of 0. So when the x value is the solution, when we substitute that value into here, we're going to get 0. However, when we use 1 and 2, we get a value of minus 5 and 3. What I'm noticing here is that we have a negative when x equals 1 and a positive when x equals 3. Minus 5 is less than this value of 0, and 3 is greater than this value of 0. So what we can write down is that there's a change in sign. So this is going to imply that therefore a solution lies between 1 and 2. And that's because we've set the expression equal to 0 and we've got out a negative and a positive value, so somewhere in between them we must have the value of 0. So the solution is going to lie between 1 and 2 because those were the x values that we put in. And the graph's continuous, so if we were to draw out the graph of this, we'd be basically looking for the root of the graph, so where it intersects the x-axis, and we have that change of sign here. So some point between x equals 1 and x equals 2, there is going to be a solution. And we've written that down here. So the first mark is for substituting the values of x equals 1 and x equals 2 into this expression here. Similarly, you could do it and leave it as x cubed plus x and then say that the values that come out, which are 2 and 10, one's greater than and one's less than 7. That also works, but sometimes I just find it a little bit easier to work with it in terms of something equaling 0, so we can clearly see the change in sign, so the negative to positive. And the second mark here is just for this little explanation at the end and getting out the correct values of -5 and 3. Or 2 and 10, and explaining why this shows that there's a root or a solution between 1 and 2. Now in this question we're asked to show that the equation x cubed plus x equals 7 can be rearranged to give x equals the cubed root of 7 minus x. Now initially what I'm realising here is that we have a cubed root in this expression that we're trying to find, and over here we have an x cubed. So if we can get some expression equal to x cubed, when we find the cubed root of it, we're going to have x equals something. So taking this expression, x cubed plus x is equal to 7. If we subtract x from both sides, we're left with x cubed is equal to 7 minus x. And this is looking familiar here because we have the 7 minus x under the cubed root sign. Now we have x cubed is equal to 7 minus x. What we can do is find the cube root of both sides of this equation. Remembering to do the same thing to both sides of the equation. And then if we look over here, the cubed root of x cubed is just x, because if we cube x, we get x cubed. And that's equal to the cubed root of 7 minus x, which is what we were asked to show here. And that will get us the mark for this question. So now for this part of the question, we're asked to, starting with x0 equals 2, use the iteration formula xn plus 1 is equal to the cubed root of 7 minus xn, which is the equation that we rearranged to find in part B. We're asked to use that iteration formula 3 times to find an estimate for a solution of x cubed plus x is equal to 7, which is the equation that the iteration formula has come from. Now we're asked to start with this value x0 is equal to 2. So if we let x0 is equal to xn, so we're starting with n is equal to 0, what we do to find x of n plus 1, so 0 plus 1, so x1 is going to be equal to the cubed root of 7 minus xn, which is x0. So just to go through that again, we have xn plus 1 and n is 0, so n plus 1 is 1. So x1, the next term, is equal to the cubed root of 7 minus x0. And we have the value of x0 that we've been asked to start with. So the cubed root of 7 minus 2 is equal to the cubed root of 5. And if you put that into your calculator, that's going to give you an answer of 1.709975, etc. And it's really important to use the exact value throughout this question to then substitute into the next part to make sure we don't get any rounding errors throughout the question. we can then go on to find x2. So this is xn plus 1 when n is equal to 1. So finding the cubed root of 7 minus x1 this time. So the cubed root of 7 minus this value that we calculated before, but use the exact value that can be stored on your calculator. And if we find the exact value of this, it will come out with an answer of 1.74241, etc. And then we can use this exact value again, keeping that stored in our calculator, to find x3. So that's using the iteration formula 3 times, finding the cubed root of 7 minus x2, and that's the cubed root of 7 minus x2, which is this value, 41. And that gives us a final answer of 1.7388, etc. However, what I'm going to do is just round that to 1.74 in this instance. We're rounding up because 8 is greater than or equal to 5. And I'm going to give that as a final answer to 2 decimal places. So as for how the marks are awarded for this question, the first mark is for a substitution of 2 into the formula. So substituting 2 in and getting out this value here of 1.7099. The second mark is for a substitution of x1 to give x2, so this point here. And then the third and final mark is for an answer in the range of 1.738 to 1.74, and we've given that here correctly as the final answer of 1.74. So in this question, we're told that we have 2 right-angled triangles, which we can see drawn below. And we're told that given that tan of E is equal to tan of F, we're asked to find the value of X. And we're also told that we must show all of our working along the way. So just having a look at the triangles, we've got the angle E here, and then we've got 2 side lengths defined in terms of X. And just noticing again, this is a right angle triangle, so this side over here is the hypotenuse, and we don't have the length of the hypotenuse. Similarly for this triangle, we have the angle F, we have the right angle, and we have 2 side lengths, the adjacent and the opposite to this angle here. Now, the fact that it's a right angle triangle is going to come in really useful here because we're working with tan of an angle. So if we have a right angle triangle, I'm thinking back to the idea of SOHCAHTOA. So this is just how I like to remember it. So looking at this TOA part, because we're working with tan of an angle, this basically says that if we have tan of an angle, so theta for example, this is going to be the O for opposite divided by A for adjacent side. So tan theta is equal to the length of the opposite side to the angle theta divided by the adjacent side. And I can just look at these triangles above, and we're working with, so tan of E firstly, the side opposite this angle is going to be this side over here, so length x, and the side adjacent to this angle is this side here, so length 4x minus 1. Just making sure we don't get confused with the hypotenuse here, which we're not looking at. We're just looking at the side that's adjacent to the angle and not the hypotenuse. So we have the opposite and the adjacent. And similarly over here, opposite to angle F and the adjacent to angle F there as well. Now what we can write out is tan of the angle E this time. So tan of E is the opposite over the adjacent. So tan of E is equal to x over 4x minus 1. And we can do tan of F as well, because that's what we're looking to kind of find here, so we can get an equation in terms of x. So tan of F is the opposite over the adjacent, so 6x plus 5 divided by 12x plus 31. Now what we can do, because we have this expression here, we're told this, we can make them equal to each other. So tan of E, which is x over 4x minus 1, is equal to tan of f. And we now have set up an expression which is just in terms of x. So we can solve this to find the value of x, which is what we need. So we need to solve this equation that we have here. And we're working with fractions, which is not the best. So we're going to start a process to remove these fractions. Now we basically just need to multiply up both sides of the equation to eliminate this fraction. And how we can do that is kind of by cross multiplying them, or by multiplying both sides by the denominator 4x minus 1 and this denominator of 12x plus 31. So if I just take this as multiply by 4x minus 1, so that's going to cancel out the denominator of the left hand side, and multiply it also by 12x plus 31 to cancel out the denominator on the right hand side. So if we multiply the left hand side by this, when we multiply it by 4x plus 1, it basically cancels out the denominator, but then we still need to multiply x by 12x plus 31. So we have x lots of 12x plus 31, and that's going to be equal to 6x plus 5 multiplied by, again, 4x plus 1, 4x minus 1, sorry, and also this 12x plus 31, but that cancels out with the denominator. So it's kind of like we're cross multiplying here, so we're multiplying this by this and that by that, so there's a cross here. So now that we have this expression, we can expand the brackets and expand the left hand side and come up with another equation in terms of x. We're just expanding everything so that we can then look at how many x squared terms and x terms we have and see if we can solve for a value of x. So if we multiply x by 12x, we get 12x squared plus 31x, and that was just by multiplying x by 12x and x by 31. And that's going to be equal to the expansion of these brackets, and I like to use the FOIL method. So firstly multiply these two. 6x times 4x is 6 times 4, which is 24, and then x times x, which is x squared. And then we can do this one and this one. So 6x times minus 1, I'm going to do minus 6x. Now moving on, we have 5 times 4x, and that gives us 20 plus 20x. And then finally, we just do this last one, 5 times minus 1 gives us minus 5. We can now simplify this down further and collect like terms, so it's just leaving the left hand side the same. That's equal to 24x squared minus 6x plus 20x just gives us plus 14x minus 5. And we can now collect the terms further, so we can subtract 12x squared from both sides, and we can subtract 31x from both sides. So if we subtract 12x squared plus 31x from both sides, we're going to get 0 is equal to 24x squared minus 12x squared, so 12x squared, plus 14x minus 31x, and that's going to give us minus 17x minus 5. So now we've got an equation equal to 0, and that was just by subtracting 12x squared plus 31x. So we have this equation equal to 0, and we can now find a way to solve this quadratic equation to find the value of x. Now we can do this in a couple of different ways. You could substitute it into the quadratic formula, or alternatively you can factorise it. So factorising this expression, it actually factorises as 4x plus 1 multiplied by 3x minus 5, and that's equal to 0. So the way that I'd do that is by looking at factors of 5 here, well, minus 5, so we either have 1 and minus 5 or minus 5 and 1 because there are no other factors of 5. And then we also need something that multiplies to get 12, being with the x terms, so 4 times 3 gives us this 12x squared that we have here. So then you can just try a few different methods and see what will work, and this is the factorisation that we come to at the end. So then we now know that one of these brackets has to be equal to 0 for the left-hand side to be equal to 0. So if we have 4x plus 1 is equal to 0, 4x is equal to minus 1, x is equal to minus a quarter. However, we originally had a side length which was x, and you can't have a negative length, so we know that x cannot be equal to minus a quarter. So now looking at the other bracket, 3x minus 5 is equal to 0. Add 5 to both sides, 3x is equal to 5. Divide both sides through by 3, x is equal to 5 over 3. X is greater than 0, so it can be a side length, a real tangible side length. So that is the correct answer here. And there we have it, we've calculated the value of x. So as for how the marks are awarded here, the first is for a process to derive an equation in x. So for deriving this equation that we have here. Then for a process to remove the fraction, so by cross multiplying out and getting this equation here. The next mark is for them reducing it down and multiplying the terms out to get this quadratic equation here. The next mark is for factorising it and setting it equal to 0, or for using the quadratic formula. And then the final mark is for the correct final answer of x equals 5 over 3. So in this question, we're told that 50 people were asked if they speak French or German or Spanish. And we're told that of these people, 31 speak French, 2 speak French, German and Spanish, 4 speak French and Spanish but not German, 7 speak German and Spanish, and 8 don't speak any of the languages. We're also told that all 10 people who speak German, so we know that 10 people in total do speak German, that all 10 of them speak at least one other language. So this also tells us that nobody speaks only German. Everyone that does speak German speaks at least another language, so they might speak French as well, or Spanish as well, or both as well. We're told that 2 of the 50 people are chosen at random, and we're asked to work out the probability that they both only speak Spanish. So we're given a lot of information here to read through and work through, and if we have a look at what we're actually working with, we've basically got 3 main categories. So we've got the French, German and Spanish speakers, and we've got the number of people that are going to fit into each category and into kind of the overlap between categories. So what I'm instantly thinking here is that we need to be working with a Venn diagram. So I've just sketched out a Venn diagram over here, and it's a 3-way Venn diagram where all of the circles are going to overlap. So we have this area in the middle where all 3 overlap. And I know that because this line here says that 2 speak French, German and Spanish, so they all do need to overlap at some point. So once I've got the diagram, the Venn diagram, I can start kind of labelling it up and start putting any obvious values in. So if I just take this circle as being F for French, and then G for German for this one, and then the bottom one can be S for Spanish. Now I can just kind of work my way logically through the information in the question and just fill in as many values as I can. So firstly, 31 speak French. Now this point is not actually going to be very useful at the start because we know that the total of the numbers in this circle is going to be 31. However, we don't know what's in each of these individual areas, so we can't actually put any numbers in here yet, so I'd have to come back to this one. However, this next point, 2 speak French, German and Spanish. So looking for the area where all 3 overlap, that's going to be the darkest area here, which is the centre, where all 3 overlap, so French, German and Spanish speakers in the centre. And I can just put in the value here of 2 because we know that 2 people speak all 3 languages. I'm just going to tick that piece off as well, just so I know that I've used it in the Venn diagram. Moving on, we then are told that 4 speak French and Spanish but not German. So looking over here, the overlap between French and Spanish is this section here. However, the overlap between French, Spanish and not German is just this point that we have here. So this section here is going to be the 4 that speak French and Spanish but not German. So I can fill that in as 4 and tick that piece off. We're then told that 7 speak German and Spanish, so the overlap between German and Spanish is this section here. However, we need to be a little bit more careful this time because the people that speak French as well aren't included in this statement, so they are actually the 7 that speak German and Spanish. We're including those that speak French as well in there. So this whole section is going to sum to 7. However, we've already got 2 in this part, so this part here is just going to be 7, subtract that 2, which gives us 5 for this section here. And then the next point, we're told that 8 don't speak any of the languages, so we can put an 8 outside all 3 of the circles. It is important that we do write that down because when we're looking at the ends to fill in the gaps, we need to make sure that all of the numbers should sum to 50, the total number of people that were asked. We're then finally told that all 10 people who speak German speak at least one other language. So we know that 10 people speak German, and we know that nobody speaks only German. So this part of the Venn diagram here would be the people that speak only German, and I know that that is 0. I also know that the total number of people that speak German, so the total of the values in this circle, needs to be 10. So I can work out this missing value by taking the 10 and subtracting the other 2 numbers, so subtract 2, subtract 5, and that gives us an answer of 3 for this section here. So now 10 people in total speak German, and none of them speak only German, so I can tick that off. I've now got a much fuller Venn diagram, so I'm just going to go back to this top line here, making sure we've been through all of the information. 31 people speak French. Now looking at the French circle, to work out this value, which is the only unknown part, we take 31 for the total and subtract 3, subtract 2 and subtract 4 to give us an answer of 22 for the number of people that speak only French. So this section here, 22 people speak only French. So I can tick that off as well. And now we've got a lot more of a complete Venn diagram, however we are just missing this one section here. However, this is what we need to work out. So we're working out the probability that they both only speak Spanish. So that is the probability that they're in this section. They only speak Spanish. And I can work this value out by taking the total number of people, which is 50, which all of the numbers in the Venn diagram should sum to, and subtracting every other value in the Venn diagram. So subtracting the 22, 3, 2, 4, 5 and 8, and that's going to come out with an answer of 6. So here we have that 6 people only speak Spanish. So now all of the numbers in the Venn diagram should sum to 50, so 50 people were asked if they speak French, German or Spanish. So all of these values will sum to 50, and we've got this value here for 6 for the number of people that only speak Spanish. So we can now use this to work out the probability that the 2 people chosen at random both only speak Spanish. So the probability that the first person only speaks Spanish is 6, because there are 6 people that only speak Spanish out of the total of 50 people that are asked. And the probability that the second person chosen at random only speaks Spanish, well, we've already taken that first person out. We can't pick that same person again. So there are actually now only 5 people left that speak Spanish because we're not including that original one. And that's going to be 5 out of a possible 49 because, again, we've subtracted 1 from the 50 original people because we can't pick that same person again. We need 2 separate people. And to work out the probability that they both only speak Spanish, we're just going to multiply the probabilities of them speaking only Spanish individually together to get the probability that they both of them chosen only speak Spanish. And when we multiply these two probabilities, we get an answer of 6 over 490, which is the correct final answer here. So as for how the marks are awarded, the first mark is for a process to kind of start processing the information. So for example, drawing a Venn diagram and putting at least one unknown value into it. So that's where the first mark is. The second mark's for a process to find at least 3 unknowns from the information that we're given. So working out the unknown values and putting them into the Venn diagram gets us a second mark. The third mark's for a complete process to find the number of people who speak only Spanish, so for finding the 6 here. The fourth mark is for them multiplying these two probabilities together. Or alternatively, if the value that you calculated wasn't 6 and you'd gone wrong somewhere along the way, just substituting in the values that are right for your numbers would also get you the method mark here. And then the final mark for this question is for the correct final answer of 6 over 490. So in this question here, we're given a diagram and we're told that ABCD is a parallelogram and that ABP and QDC are straight lines and that the angle ADP is equal to the angle CBQ, which are 90 degrees. Now I'm just looking at that diagram. So ABCD, this shape here is a parallelogram. That means that AD is parallel to BC, because parallelograms have two sets of parallel sides. So these two are parallel, and that's denoted by this little arrow that we have here. And we're also told basically that AB is parallel to DC, but ABP is a straight line and QDC is also a straight line. So if AB is parallel to DC, ABP, this whole line here, is parallel to this whole line here, and that's denoted by these two little arrows. There's two here just to show that these two lines are a different set of parallel lines that aren't parallel to the other set. We also have the two right angles that are already drawn out here, which are 90 degrees. And we are asked to prove that the triangle ADP is congruent to the triangle CBQ. So ADP is congruent to the triangle CBQ. Now, the word congruent here is obviously jumping out to me, and there are a few different ways that we can prove two triangles are congruent. So, proving that they're congruent, we need to prove that they're exactly the same. They have the 3 same sides and the 3 same angles. And we can do that by showing that the sides of one triangle correspond and are equal to the sides in the other triangle. So side, side, side. We could alternatively do side, angle, side, so showing that 2 sides in one correspond to the other, and then there's an equal angle in both triangles, which is in the same place. Alternatively, we can do angle, side, angle, so this is the same, but showing that there are 2 angles and a side in the first one, which are equal to 2 angles and a side in the other triangle. We can't, however, do angle, 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 because this could lead to the 3 angles in the triangle could be the same, but the triangle could be scaled up or down, leaving it with different side lengths. So this doesn't prove congruency. So we basically need to look at these and find a way of proving that these triangles that we have are congruent. Now what I'm initially noticing here is that we already have 2 angles. Both triangles have a right angle in, they both have a 90-degree angle. So we're going to be using one of these two. So we need to work out how we're going to prove this. We need to find other sides and angles within the triangle which are going to be the same as the other one. So I can firstly write down that we have 2 right angles here. So we have the angle ADP is equal to the angle CBQ. And that's what we're given in the question. We're told that both are 90 degrees. So here, we've kind of given our first point of reasoning in this proof. We have an angle which is equal in both triangles. So then moving on again, looking at the triangle ADP, we have this side here, side length AD, and side length BC. Now these are parallel, they're in a parallelogram, and opposite sides of a parallelogram are going to be equal. ADP is obviously, the side length AD is obviously in the triangle ADP, the side length BC is in this triangle here. So we have an equal side length in both triangles, and I can write this down too. So AD is equal to BC, and we do just need to give a little bit of reasoning here just to support our proof. And I'm just going to write down the opposite sides of a parallelogram are equal. And that is enough reasoning to get us the marks here. So we now have an equal angle and an equal side length, so we need another angle or another side length. Now again, thinking of the properties of a parallelogram, instead of opposite sides this time, I'm thinking about opposite angles in a parallelogram being equal. So if opposite angles in a parallelogram are equal, and this is the parallelogram we have here, this one's not going to be too useful because it's already including the right angle. Then we've got this little extra angle here, which isn't an angle in the triangle we're interested in. However, these two angles, these opposite angles, are interesting because those are in fact in the triangles that we're looking at. So triangle ADP, this angle is in the triangle, and in this triangle here, it includes this angle. And we know that these are going to be the same because opposite angles of a parallelogram are equal. So I can write that out as the angle PAD, so PAD, this angle in here, is equal to the angle QCB. And again, just writing out the reasoning, and that's because opposite angles of a parallelogram again are equal. So we've given that reasoning here. So now we've proven that there's an angle and a side and another angle in the first triangle which is equal to that of the second triangle. So we can therefore conclude that therefore the two triangles must be congruent. And that is by the principle that we've used, angle, side, angle. So there are two angles and the side. Now, as for how the marks are awarded for this proof question, the first mark is for one of these first correct statements for kind of starting off the proof, identifying a pair of relevant equal sides or angles with reasons. The second mark is for all three of these correct kind of points and with their respective reasons. So we need to make sure we state the reasons as this is a proof. And then the third and final mark is for a conclusion of the congruency proof, and we must refer to the ASA, angle side angle principle in this case. Just a reference to that gets us the third mark for the conclusion here. So now for the second part of the question, I'm asked to explain why AQ is parallel to PC, so explain why these two sides are parallel. Now initially here, just looking at these two sides, I'm thinking back to part A of the question. So we were working with a parallelogram and we used the fact that opposite sides in a parallelogram are equal and that they're parallel to one another. Now looking at this shape that we have here, now looking at AQ and PC, if we were to take this shape APCQ, kind of linking these two sides that we're interested in together, if we could prove that this were a parallelogram, we'd be able to show that these two sides are in fact parallel, which is what we want to explain. So if we look at the other sides, AP and QC, now these are both part of the triangles that we proved were congruent previously. So AP is the hypotenuse of this triangle here, and then QC is the hypotenuse of this triangle here. And we know that the triangles are congruent, so their hypotenuse must be equal. So that is the first point I'm going to make here. I'm going to say that AP is equal to QC. And that is since triangle ABP is congruent to triangle CBQ, and that's what we proved in part A. So now using this, we know that these two sides are equal, and they're two equal parallel sides, which we can therefore take as the opposite sides of a parallelogram. So, going on a bit further, if these two sides are equal and parallel, and we can basically join them up with these two sides to create the parallelogram, we know that these two sides must be equal and parallel. So now we just need to explain why AQ is parallel to PC, and we can just reason that APCQ is a parallelogram. It has two sets of parallel sides which are equal. So AQ is parallel to PC as opposite sides of a parallelogram are in fact equal. So the first mark here was awarded for this initial reasoning, so for identifying a pair of equal sides or angles would also work in APCQ, this parallelogram, with some reasoning. And then the second mark here is for reasoning that APCQ is a parallelogram and its opposite sides are therefore parallel and equal. So we therefore have AQ being equal and parallel to PC. So we've explained why the two are parallel.